Hello everyone and welcome to part 2 of my Kaggle project from scratch series, where I explore some of the data from the Kaggle developer survey. I recommend watching part 1 if you aren't familiar with project planning or how to join a Kaggle competition. If you're comfortable with those, you can jump right into this. In this video, I'll go through how I approach some light data cleaning and exploratory data analysis. This video is more focused on teaching the process rather than on truly finding unique insight. I'll focus more on the questions I ask of the data and the steps I take to frame an analysis than on the code I write or the actual solutions that we come to. I built all of the graphs in this analysis using Plotly, which was a completely new tool for me. You'll get to see how I approach learning with something new by getting my hands dirty. I recommend following along on Kaggle, and I've linked the notebook below in the description and in the pinned comment. Feel free to give this video a like and the notebook an upvote if you found them helpful at all. So this code took me about 8 hours to write, and I won't be going through it semi-live like I have in some of my other videos. I really think it's important though for me to show the problems that I run into and the steps I took to overcome them. So I took very careful notes on my stumbles and the resources I used to get through them. I'll walk through the code and I'll also walk you through my process of error resolution. I'll stop where I made some errors or some blunders, and I'll explain what I did to get past those. Now, let's jump into the analysis. Okay, let's do this. So, just a quick recap of part 1. I showed you where the video is right here, and I'll also pin it, link it everywhere. Showed you how to join a Kaggle competition, how to read through the documentation associated with the competition, or just how I do it, how to understand the evaluation criteria, how to download the data using the Kaggle API command line interface, how to review other people's kernels to kind of get the juices flowing with creating your own questions. And then we went ahead and created a couple questions that we wanted to answer through the exploratory data analysis. So those questions were first, the difference in positions. So a data analyst versus a data scientist, what can be expected of them? What tools are they using? How much do they make? And this is what we're going to focus on. We're going to start to answer this question in this notebook. The second thing is gender differences. And we might try to create a regression or use some advanced techniques to understand that better. Now, again, in this notebook, I'm going to do some data cleaning, data manipulation, and I'll start creating some more advanced graphs. And then in part 3, I'll finish off those advanced graphs, build a couple more, and then tackle this whole gender differences question. These are the notebooks that we referenced in that last video. If you want to check them out, they're all really good. I learned a lot from them. Now, part 2, which is what we're on now, I first want to say that when we're doing exploratory data analysis, when we're doing one of these projects, organization is unbelievably valuable. Before I do any project, I outline it. I go through the steps after looking at the data, and I try to understand what the story is going to be, what I'm going to do at each step. I try to essentially make a checklist for myself about what what I'm going to do with my time. And that's really good also for motivation, for actually getting a project completed, because you have something to check off. I have a high level understanding of the data. I do these 4 things, I check them all off, and then I can move on. You can keep track of your progress more easily. You don't go down those rabbit holes. You have something to tie everything to. So that is my first recommendation when you're doing an exploratory data analysis. Just write steps for yourself. This also makes it very easy to document afterwards. I've done all of this in Markdown, and I recommend, if anyone else is going to see your work, you should essentially always do something like this. This is to get you into my mind, which admittedly can be a fairly scary place, but I'm just going to walk you through my process, how a data scientist approaches a problem like this. That is the real focus here. So let's just start with the code here. So we're going to import the relevant modules, pandas, numpy. We're probably not going to use matplotlib because we're focusing on Plotly, but there's 2 different Plotly modules we're going to explore. So Plotly Graph Objects and Plotly Express. They're just a little bit different, and I'm going to explain why we're going to use both of these and what the subtle differences are there. For this is just for the Jupyter Notebook, so we can see a lot more data. I really like to explore the tabular data, just visually looking at it. I think that that's a good practice to get into, so I expanded it out. Otherwise, we'd only be able to see just a little bit of it. Next, we're going to read in the data, and we're going to look at the shape. So as you can see, there's a little more than 20,000 columns, 20,000 rows and 355 columns. So I think that there's only 30 or 35 questions, and you might be wondering, why do we have more columns than questions? So some of the questions, like question 7, I believe, you can have multiple answers to. And in that case, there's multiple columns for all the different answers you can give. So that's something we have to consider, is how do we build a graph for when the data is formatted like that? And I'll show you how I manipulate the data so I find it easy to graph that. Next, we'll just kind of describe the data. I really like doing this for everything. It gives you some central tendency, the most frequently cited I guess answer in a lot of these things, and we can just look a little bit better at what the data is. So it looks like there's 35 questions. There was also a bifurcation if you answered I think one question, it was probably 27 or something, in a certain way, you would get a different set of questions for some of these other ones. So like anyone that has an A, there's an accompanying B, and that's based on how you answered one of the previous questions. Next, I like to go look at the individual data. So the head just gives us the top 5 rows, and we can see how all of the questions are structured. Obviously, this top row we're going to have to do something about because that's where the question is asked. So that'll mess with our data if we keep that in there. But a lot of nulls, and we can basically go through and read a lot of these questions if we want to. I went through a lot of the questions in the last video, so I don't think that that's super practical to do here. This line of code here, we're just going to remove the top row, which is the one that has what the questions are, so that we don't have to do that later. And maybe this was lazy. I just look at this as like the final data. That's why I do df_fin. Now let's look at the head again, and you can see that top row is not there anymore. I always like to look at null values. That's something that is particularly interesting to me. And in this analysis, we're going to start by just looking at what values are null. We're going to expect a lot in some of the questions, especially the parts. But as you can see, some of the early questions, if we go up here, so, what was one that had some null values? So question 4, it looks like, had a few null values. So what's the highest level of education? It looks like some people just chose not to answer that, left that blank. And those are things to consider when we're building out graphs for these. I don't think we're going to have to really do any imputation here because it is survey data. We probably just want to remove the ones where there isn't anything put in, because we can still aggregate on other things and look at the percentages. What I found with this is I wanted to be able to analyze each of the individual questions in isolation if I wanted to. And I thought it was difficult that there were a bunch of different parts to each question. So I did a little bit of data manipulation so that I could just reference a single question if I wanted to. And that's what this whole code is here. So for the questions, I made a dictionary, and each question I put into its own key value pair. So I would have question 1, and it would have all the data for question 1. I would have question 7, and it would have the data frame with all the different parts of question 7. So again, here we make the dictionary. Here I just make a list of all of the different questions. And we did that by splitting on the underscore. So as you can see, all of these questions have a first underscore here after the number. And then we just took that first, when you split on an underscore, when you split on anything, it creates a list of parts before and after each splitting criteria. So in this case, the first split is going to be the question number in all circumstances. So now we have this beautiful list of all of the questions here. After that, we take that list, and we had to do, I'm going to talk about this line in a second here, but we essentially just took all of the columns that start with that question, and we loaded it into the dictionary so that we could just go in and reference a question and get all the data like I'd mentioned before. For question 1, 2, and 3, those are a little special circumstances. So since we're just looking at if it starts with Q1, Q2, Q3, all the questions in the teens would be put into question 1. All the questions in the 20s would be put into question 2, and we didn't want to do that. So we just treated these a little bit differently than the other ones. So let's run that code as well. Now that we can look at questions in isolation, I thought it would be cool to do just a couple light Plotly graphs to get familiar with how it works. This is almost the exact process I used. I wanted to create a histogram and a couple other light graphs. And so the first thing that I do is I go and I find in the documentation of Plotly a histogram. And so we're going to start with Plotly Express, and we're going to start with question 1. So because question 1 through, basically through 6 don't have multiple parts, we can just get the data from the data frame. And it's also pretty easy to compare to other different, questions that are of that same format. So if we just look at question 1, we can see that it's categorical. They're all age-based categories. And essentially what I did to create this first graph to understand how it works is I went to the the Plotly histogram documentation, which is here. I'll have all the links below. And I just looked at how this was, and I basically copied it and pasted it into my code. That's fine to do from documentation. I'm also telling you now that I'm using the documentation to do that. And then I just filled it in with my data. So if we look here, essentially we're using Plotly Express. We have a histogram, we put our data frame in, and we put what column we want to use. So in this case, we wanted to use column 1, and we can see that this has created a histogram of our data. I mean, that was really easy to use, and that is with Plotly Express. So Plotly Express is different from Plotly Graph Objects because Plotly Express, you're essentially always putting the data frame in as a parameter, and then you're using other parameters to manipulate the data frame. So you can choose which columns you want from the data frame after you put it in. I'll show you how Plotly Graph Objects is different in a second, but let's just do one more graph with Plotly Express. I mean, this seemed pretty easy to use, pretty intuitive. Next, I wanted to do a density heat map. So I wanted to look at the, let's see, I forgot what it was. So I wanted to look at question 1. So the age of people versus how many years they've been writing code. Essentially, we know what we'd expect to see. We'd expect to see a lot of heat around people that were older writing more code and writing code for longer, and people who are newer writing code for a shorter period of time. But I just wanted to test if that was true for data science. So just like in that previous one, I searched the Plotly documentation for heat maps, and I got this for Plotly Go, but there's also, I believe, a Plotly Express. Maybe not. Getting ahead of myself there. Okay, here we go. Okay, here we go. So Plotly Express. Most of these were we're just looking at one set of data like this, but I realized, or I just experimented to see if I could put two different types of data, an X and a Y value in, and it ended up just working, which is pretty nice. So a lot of this is just through experimentation. It does look like the heat map takes an X and a Y axis. And I was able to build this graph. At first, this was not ordered, and I was a little bit confused. So I searched documentation again, and it looks like I found this one where you could basically order the axis for a bar chart, and by a category array. This seemed to make logical sense to me. So I went in and I tried to do that with my graph here. So let's see if I can find a better example of that. Yeah, so we do category order. I didn't use category array. I think I used let's see here. What did I use? So from some of the documentation I looked at, I could just put a dictionary and the order that I wanted things to be in. So for each of the axes, I put them in the exact order that I wanted, and it ended up turning out like this. So just to walk you through my whole process there, what I most likely did was I said, okay, heat map plotly, order axis, and then you can either look at the community, you can look at a couple of these different ones. I remember this one not being very good. Categorical axes. So we can update it like that. Here we go. So category orders, it looks like we just have a dictionary, and for each of our variables that we're evaluating, we can choose what order they go in. So I was able to take some of that code and just apply it to my graph here. I recommend just experimenting a lot with these things, looking at the documentation, looking at the examples they have. Almost all these visualization tools have a ton of examples, and you can also Google examples from other people. The next thing I wanted to explore was question 7, which has data in a little bit of a different format. So as you can see, each part has a different programming language, and we have to figure out how to evaluate that in a different way. So Plotly Express, I didn't find it as easy to use because the data frame is not a traditional data frame as you'd use it to visualize. So I wanted to go in and try some other tools or find a way to make that more intuitive. As it turns out, Plotly graph objects made a lot more sense here. So remember how in Plotly Express, we would feed in the whole data frame? In Plotly graph objects, you're almost always putting in just the data. So I'd put, instead of X in parentheses, I put X and I put the data series, and then I'd have Y and I'd put the data series in there. So that's a little bit more flexible. You're doing a lot of the data manipulation before you put it in, rather than with the module itself. So I built this graph, and let's walk through what some of the code here is. So again, a very simple bar graph showing the prevalence of these different coding languages across the survey answers. So what we're doing here is we're just taking the columns. So that is up here. Oh, not up here. Sorry, I renamed the columns up here with the language they represent. So let's just show what that looks like real quick. There we go. So now we can see the column, the columns have changed there. Next, we reset the index, and we aggregate all of the counts. So let's just show what that looks like. So we format the data frame differently. So basically what we're doing is we're aggregating everything. You can think of a group by the column names. And so we have all of the different programming languages there. Next, we'll go through and update the column names for that. So we can just do q7.columns. And so what we're doing is just changing these right here. There we go. So it's language and count instead. Next, we're going to sort them if we want the graph to show as nicely as it did. Otherwise, it's all over the place. And we create the figure here. So q7.language is just taking all of the series from that first column, and q7.count is just taking all of the series from the second column. So let's just do q7.language to show, and we'll see that before. That's what it looks like. That's what's being fed in right there. That's this axis, and then the next axis is going to be count. And as you can see down here, that's just all of the counts that match with all of those things. If things don't match up, there's a different number of counts and languages, you're going to have a problem. So that's something to definitely take into account there. So now that we have just a basic understanding of Plotly Express and Plotly graph objects, if I were to continue down that road, I would build essentially some light visuals for all of the different questions that I was particularly interested in. I think it makes more sense to kind of frame this analysis or target this analysis towards the questions that we'd addressed before. So we're going to kind of stop the broad exploratory analysis here and move into a more targeted one. So the first question that we wanted to answer, again, is related to the data science roles. So just like with the questions where we organize them into a dictionary, we're going to organize all of the roles into a dictionary. So with this, we're just creating the dictionary. In this, we're taking all of the answers in question 5, which just has all of the different possible data science roles. So student, a software engineer, research scientist, machine learning engineer, and we're giving them a key value pair, and we're filtering the data based on the people that responded with that being their type of role. So if we run that, you can see by doing keys that the dictionary keys, we have one for student, data engineer, software engineer, data scientist, data analyst, research scientist, other, currently not employed, statistician. I think you get the idea. So let's just look at roles for students. This is a snippet of the data, and we can see just the general broad distribution of things here. And you can see that there's 5,000 students in this data set of around 20,000, which I think is pretty interesting. So let's dive into a kind of sub-question here. And how does education level vary by role? So, I would imagine there's master's students, but what I almost always get asked, like, Ken, do you need a master's degree to become a data scientist? And I always tell people, no, it probably could help, but you can do it without one. Let's see if that's legitimately true or not. So the first thing we're going to do is we want to create a graph of just the baseline. So what does the whole sample look like for degree wise? So here we're just making, I can just show you what this looks like. Here we're just showing how many people have master's degrees, bachelor's degrees, doctoral degrees, and the whole set. And then we're going to visualize it here with Plotly Go, which we used before. So as you can see, master's degrees are most common, bachelor's degrees are second most common, then doctoral degrees, some university, college, professional, etc. Now let's look at what that looks like for a data scientist specifically. So here we're just using our roles dictionary, and we're choosing the data scientist data frame, looking again at question 4, which is the what role are you in question, and we're aggregating the value counts and then plotting them. So as you can see, definitely more master's degrees for data scientists, but it looks like almost a third of all data scientists only have a bachelor degree, which I think is pretty normal. And it does show that without a doubt, you can become a data scientist without a master's degree. So let's build a bit more of an advanced graph. And this is going to be kind of a new segment that I haven't done before. I'm going to show you essentially 4 iterations of a graph that I tried to make. And you can see kind of the struggles I went through and how I eventually got to the end product. So let's actually jump to the end product, and then I'll show you how I eventually got there after quite a lot of work. So the end product here is, I guess it's a little too cramped. Give me a second. There we go. I guess it doesn't match screen size, which is interesting. Oops. Okay, so the end product looks like this. There's 2 drop downs. I'll clean that up later, but there's 2 drop downs, and you can choose 2 different roles. So a data engineer, and you can compare the education levels between them and maybe a data scientist. So this is selection 1, and this is selection 2. It's a little hard to see right now, but again, that's why we test things. And so you can see that data engineers have slightly less instances of master's degrees than data scientists. There's a lot more that have bachelors. Let's look at like a research scientist. you'd expect research scientists to have a lot more doctoral degrees, and that's true. So, I didn't just build this right away. This took me quite a bit of time, and there's 4 different versions of this that I went through in order to get there. So let's start with the top of how I ended up trying to build this. So this first iteration, essentially what I did is I just Googled, um, how to make a drop-down menu in Plotly. And these are the 2 articles that came up. So the Stack Overflow and then the Plotly dropdowns. I started with the filtering data here, and I used this person's code. I believe it's Vestland, which is really awesome. So essentially, I copied this in and replaced it with my own data. That's generally my first step. I just want to get something running, and I want to try to get it to work, just to show a graph on the screen. And so what I did here is just walking through this at a high level. With Plotly, just like in Matplotlib or in some of these other graphing libraries, you can create a figure. That's just like the plot. And then you can add a graph to it. So the trace is our bar chart that we're adding. Next, you want to figure out what goes in your dropdown. So in this case, they're called buttons, and you want to append a couple different buttons here. So the buttons here are just the different graphs that we're going to create. So we're going to create one for a data scientist, one for a student, and one for a data analyst in this use case. We're not going to have all the other positions in there. I like to just boil things down, make it simple, and then we can make it a bit more complex with more variables down the road. I actually didn't know what any of this code did, but it was in the other one at this point in time. So I just left it and kind of prayed a little bit to see if it would work. And as it turns out, it did. So we can change student, we can change to data analyst, we can change to data scientist. But it took quite a bit of playing around with this stuff to be able to get it to work. So I struggled a little bit with, understanding what would go in here. So we're using the Plotly graph objects. So we're just putting the data series in. We're not doing it with Plotly Express, where we're putting the whole data frame in. I didn't understand what the method was, restyle meant. I didn't really understand a lot about this. I just realized that I could get it to put something onto the page, which I think is the first step, especially with visualization. You want to understand the underlying mechanisms, for example, with machine learning, or understanding why you're using a certain algorithm. But for this, you're trying to create something, you're trying to build something, and what's most important is how it looks and how people are interacting with it. So the next thing I did was I went to a second iteration, and I wanted to create a baseline where I could compare these different people against just the average population, which we had up here. I also, instead of doing raw counts, I wanted to look at the percentage of that population that had that level of education. So right here, the first thing I did is the first change that I made is I added a title, and I just Googled essentially how to add a title to a Plotly figure. That was relatively easy. Next, I added another trace. So I just added another graph. I actually didn't know what that would do. And it ended up adding another series of bars, which turned out to be what I wanted in essence. At first, I was planning on having 2 graphs and comparing them that way. But if I can compare them on the same chart with 2 different bars, I thought that was really cool, like the blue and red that you saw below. The next thing I did here was actually the other, this one does it in this way as well, is they used a loop to add the buttons for all of the columns. Before I tried a base case with just 3. In this circumstance, I now did it with all of the different roles. And I also just kind of prayed that it would work, and it did end up working. At this point, I still have no clue what that did. So I was just kind of going through the motions there and trying to figure it out. And I wasn't going to mess with it until I needed to, or if it broke something, whatever that might be. One last thing I did here was I also added the order. So as you can see, this is in order of like most common to least common. I wanted to order it by education level, so most educated to least educated. And we did that with the same category array that I found in that other bar plot here, this category order. So as you can see, I mean, me just going through the documentation a lot and also just knowing to search within the documentation like order or some of these keywords is how I come to these solutions. Usually you don't just read the documentation. I use Control F all the time and I just search through it and try to find it as quickly as possible. So you should be able to see from this graph that, hey, we have 2 bars now, which again was an unintended consequence, but it ended up working out really well. And now when we switch between, for example, data scientist, we can see that all of the data, the average data scientist has 40% of them have master's degrees. Oh, I'm sorry. All of the data, the average of the data has 40% have master's degrees, whereas data scientists, about a little bit over half of them do. And then we can also compare like a statistician. So that's a little bit more of a level playing field, but a lot more have doctoral degrees. And then maybe let's look at a business analyst where, it looks like a large portion of business analysts have master's degrees too. Maybe that's a slightly different type of master's degree. Maybe it's MBAs as well, not just master's in computer science or data science or whatever that might be. So I think that's a very useful tool now. We can compare against some baseline rather than just showing some stuff on a graph. Now, the next thing I wanted to do was really get to that, to having 2 drop downs. And I will tell you, this took me probably the longest of this whole project. I was completely at a loss for how to do this, but I figured I knew how to have 2 bars on there. Why wouldn't I be able to have 2 drop downs? And so essentially the steps I took is I made another set of buttons and I added that to buttons 2. I actually don't know if I really need to do this, but it seemed like it would make sense is that if we have 2 drop downs, they would need 2 sets of buttons. I also just made sure that the different trace was lower down. I actually don't think I need to do this as well. I learned later that this 0 or this 1 is what attaches the buttons to this specific trace. So I could have put this trace up top, but that's how I was thinking about it. I also finally figured out what this update menus does. So this controls all of essentially everything about the dropdowns, where they're located, the direction that they open up, and it attaches the buttons to the different dropdowns. So I really struggled with this. It wasn't till I just randomly put in different numbers into there, trying to tweak it and trying to see what that would do. It wasn't until after I did that I actually got the multiple drop downs working. And I also changed the different height of the drop downs and where they were located after looking at just a lot more documentation, but mostly mostly right here. So as you can see, there's in all of these graphs, the drop downs are at the top. So I just kind of copied a lot of this formatting in the direction of the buttons there. And then let's see here. So then this was good to go, but there were still a couple things that I needed to clean up. So, nope, that's not the correct one. It's up here. So we have 2 drop downs, and when I'm on widescreen, this looks a lot better. So I need to figure out how to frame, oops, you can't even really see it. I need to figure out how to frame this to make it static, where the size of the window doesn't affect the placement of these things. But I wanted to update the list here. I also wanted to add some text here to let people know which selection they were talking about. So then I essentially went down and I copied this code from this graph, which allows us to put those in. And what else did I do? And then I also changed this rule selection, all data selection up here. So we have selection 1 and selection 2. So now when we run this, which I ran at the beginning, we should be able to see that it looks a little bit better. We can compare the two selections. We can compare a software engineer to all samples or to a data analyst. I guess I also added this all samples thing here. So I just appended one more thing beforehand that had all of the samples onto both of the buttons lists. So before, you couldn't actually get back to that all samples thing without resetting the graph. So I went through and, it took me 4 phases to get a graph like this that, frankly isn't even all that impressive. But it didn't start with me just saying, I know how to build this graph, I'm going to go about doing it. It started with this incremental process where I improve on each iteration to begin with. So I think that's as much time as I want to spend on this video. I've shown you the process of how I get to building some of these graphs. In part 3, I'm going to build a couple more where we compare some of the different tools perhaps, or some of these other things across these same positions in a similar fashion. And then we're going to start tackling that gender differences question. I expect I'll be able to do it all in one video next, but there might be a bonus part 4 if that is not the case. So I hope you enjoyed this video. I hope you found it informative. This is a little bit different because we're looking into my process and how I approach these things. Hopefully, again, this makes data science a bit more approachable because you're understanding the steps that it takes to get to an end solution rather than just seeing the solution that's out there. So thank you and good luck on your data science journey.